Hello, hello, hello. Looks like we're good. Just give this a quick share. Cool. Hope everyone's doing well. See if we're live. Everything's good. Say hello. Right, what are we doing today? So yeah, I've done quite a lot off stream. Quite a lot, basically cleaning up all the bindless stuff that we did. So yeah, it's now, yeah, now we got to start moving on. Now we got to start thinking about what to do next. There's a lot of things I want to do. One of the things I want to do is have a skybox. I haven't written the code to make a skybox since the Minecraft clone I made in 2022, so it's been a while. I mean, I thought about just writing it outright, but the problem is with that, we end up in a situation where I just keep adding more and more different graphics pipelines without doing the SPRV reflection stuff. So at some point, the combinations of shaders are going to get out of hand. I mean, to do the transparency, even in this scene, once it boots up, for the sponsor, for all this stuff that looks like goop at the moment, it's like big goopy stuff, and this chain, it's about 4 different graphics pipelines. No, it's 4 different combinations of shaders that can reuse the same pipeline, but once you get like different numbers of pipelines and different combinations of shaders, you end up in this situation where you're having to write lots and lots of different graphics pipelines. So that's what I'm going to try and do. I'm going to try and start the parsing of the binary, parsing of the SPRV code. Now, I know there is like a SPRV reflection GitHub. I'm aware that exists, but I've always written my own. I've seen other people write their own. I think eventually I will move over to it. But I think to begin with, having like a small subset of what's actually there is like a really good start. So I could be wrong with that. I could be like wasting my time here, but yeah. So I'm a bit like shaky on this again. But yeah, we are fully supporting bindless at least. We deleted a bunch of code yesterday, which is really nice. And I think my idea is to add transparency than a skybox, because transparency is, necessary for any type of scene. And then I can easily just start tacking on different graphics pipelines like a skybox with the 2 different shaders. I can start adding billboards for different lighting nodes and stuff like, like general shader stuff. So that's what I'm going to be doing anyway. So yeah, we'll see how this goes. Yeah, so we've got to start somewhere. That's effectively what we're doing today. We're starting from somewhere, building some basic stuff out. So I'm going to start off with like a really basic SPRV thing I've written in the past. But I think then I'm going to start modifying it based on what I've written in the past. So this will be very similar to anyone who's followed the Mastering Graphics Programming with Vulkan. I'm not going to claim this is completely unique, but it eventually will get more and more unique. Oh yeah, and that's the other thing. I've moved away from gltfc.exe. The actual output of the... Hey Heath. Yeah, not bad. Just gearing up for figuring out what we're doing today with parsing different shaders. So this is what we're parsing. We're going to start trying to parse today. This type of the opcode of the shaders. So hopefully that'll help us build up different graphics pipelines with a bit of automation. And I've moved away from glc.exe, which is just a wrapper around this anyway. The opcoders were a lot more... It was so much more condensed, and I don't think... If I'm going to parse it, I've got to stick to a particular type, and I've only ever parsed SPRV code that's come from the GLSLang validator compiler. I didn't even ask, how are you doing, by the way? My bad. So yeah, it's one of these things where it's like, I could just like learn the different opcode, but I don't want to. Just because it's a wrapper and it allows me to do hash include without an extension. Like, I can just add the extension in. So that's what we're going to do today. Yeah, it's a little bit too complex for me as well, to be honest. I don't know how much we're going to get done today. But you know, the idea is that we end up in a situation where we can do a lot of, like, you know, nice effects. We can stack effects on top of each other. So we can do like depth of field and then have like a, I don't know, a bloom effect on top of that, and then maybe even depth of field, bloom, post-processing effect after post-processing effect, you know, all those type of things. So that's the idea anyway. So it's like it helps with development in the long term, for things that happen in the short term. Yeah, so this is a bit... Parsing the actual opcode is going to be interesting. SPRV... I don't know how you would do this in OpenGL. Like... like, considering you compile this on the, you know, on the fly. I'm using pre-compiled shaders to do this. I wonder if you can do SPRV stuff with OpenGL. Anyway, no idea. All right. Let's see. So okay. So let's begin. All I need, actually, let's oh, what am I doing? I'm in the header. SPRV yeah. Parse HDR. I kind of like this way of defining header guards rather than pragma ones. I'm sure people will disagree with this, but you know. So what we're going to do is basically fill up some structs. Hopefully we can get this working. I think it'll be a success if we get a... No, what do I need? I need to think. So for now, I'm just going to literally write a function that we're just going to access. And yeah, we're going to start there. We need, at the very least, we need platform. Probably more than that, though. This has a bunch of stuff in it that allows me to do compile size data, which is kind of nice. Although this will just be a pointer. We're going to be going 4 bytes at a time, I think. So we'll see if I can do this right. Data size, we want this to be 8. I need some kind of buffer. So that is part of the foundation class string. Because we're going to be passing a bunch of strings, so I think. Ugh, this is a bit. I'm rusty as hell with this. So parse results. So this is the output variable. What do I want this to be? So yeah, this will create descriptor layouts. So if I make a struct, parse results, we will need GPU resources, which is where the graphics. This what we're doing here is we're basically going to create a function that spits out a bunch of descriptor set layouts, which is basically what you need for this. So yeah. Yeah. So we'll see. So we need the set that we're on. Let's say set index. And the descriptor set layout. So this is the struct that we use to create the descriptor sets. And whatever. Let's just do a const expr total s total layout or something. Total sets. I don't know. Unit 32. Okay. So this is output. So output. So now we have a thing that we need to output. So that's done. SBRB. So here we go. Here it begins. Yeah, to solve something in particular. Yeah, this we're parsing this. This is a decompiled shader. I don't know if you've ever seen SBRB before, but what you can do is you can investigate the uniforms and the bindings and all that kind of stuff. Sorry, the buffers and stuff like that you end up using. And then based on the parsed code, based on this, what you found here, like this local constant is a uniform, which I think is further down somewhere. Yeah, this, right? It tells us it's a uniform. And this is what we're after. We're after this kind of stuff that tells us that we have a uniform here, whatever the binding is and all that kind of thing. This then with this parsed shader file, then we can then create a struct of data that then is used to build up a graphics pipeline. And what that allows us to do, instead of having to write a bunch of graphics pipeline, basically we write the shaders first, and then we generate the descriptor set layouts, which help us build a load of graphics pipelines. Which means that we can have like tons of different, like I said before, like different results. We can like write a shader, then we don't, because otherwise you have to like write every single graphics pipeline yourself, and then there's different variations of that graphics pipeline that you have to worry about with different descriptor sets and different materials or something. So yeah, this is what it's trying to do. It's trying to solve that type of problem. So hopefully this solves something. We'll see how we go anyway. This might be a big fail where we just end up spinning our wheels. But yeah, I'm just going to be stepping over the opcode bit by bit. So we'll see. What do we need? So let's write the... Let's get this out. So yeah, this is like one of the most confusing, not confusing, it's hard to explain, SPRV reflection. Because you end up having to write the shader, compile the shader, decompile the shader into opcode, which is different from text, then parse the opcode to then build up the graphics pipelines, descriptor set layout, and then you can build up multiple graphics pipelines. Hopefully that makes sense. Hi, Adam. Yeah, that's what we're doing today. It's not. We'll see how far we get. So yeah, we're basically gonna be switching over a bunch of words and working that out. Hope everyone's having a good day. So we can assume that if the data size isn't divisible by 4, we have gone horribly wrong already. So because each word that we're going to be manipulating is 4 bytes long. So if the data size is equal to 4, modular 4. If that is equal to 0, then we're good. Probably make a message so I don't go insane. The parsed code, the opcode size isn't divisible, might be corrupted. Yeah, because I think if we had a school's cancelled. Hell yeah. Yeah, if honestly, if you give me some advice on the way, I've done this before, but it's been a while, and also, yeah, this is a bit of a tricky one. So yeah, thanks Direct Flame for the offers. Good luck with the uni work, man. Yeah, thanks for saying hi and thanks for commenting, dude. We'll see how this goes. All right, so we want to start extracting the words. So how many words do we have is the next thing we need to figure out. SPR word count, probably. It's probably a good way to say this. Equals a uint We don't want it to be a float. Data size divided by 4. Alright. So with that, now we need to check if we have the magic number of the code of the thing that we care about. So for anyone who's wondering, I do have a second monitor that I'm going to look at, because I'm going to type something and it's going to make me look like a genius, but I'm in a second. I have not got this memorized, I promise. So magic. So OXO 7230203. Yes, I have that memorized 100%. Yeah, so this file is not a SPRV file. All right, so let's just see if we get that far and see if we can get out of this. Oops, before we start. All right, so 9. Nope, that's 0. Put a breakpoint there, and now we want to that's the thing. The way I've done this before is I've written SPRV reflection myself, because I only get a subset. I've seen basically Arseny couple can do the same thing. Book I'm reading has done the same thing. I've written one myself. This is I'm basically just trying to get a very small version of the SPRV. I want to start off with like a subset so I can then, I don't know if this is a good idea. This might be a terrible idea, but I'm going to write like a really small one and then get the SPRV reflection library and kind of like see if I'm doing the right thing, because at least I have like a base to start with where I'm like, okay, this works. Does the one I'm using, am I using it right, etc. So might be a bad idea. That's the plan anyway. So yeah, we're gonna give that a shot. Hopefully, if you've got more experience and you think this is silly, I'm more than happy to have a look at the actual code and see if I can work it out. But so yeah, it's sorry, I'm just trying to grab something. I don't want to talk too loud because I'm right next to the microphone. I don't want to deafen everyone. Okay, I'll give it a shot. Give me a second. I'm gonna parse this. What I'll do then, instead of writing loads and loads of code for all the enums, I will write this tiny little version where I just check the magic number and see if I can get the same thing with this library, and then work from there. I think that's probably a decent idea. Excuse me. Change the music. Yeah, okay, there we go. I was getting a bit repetitive. Yeah, because I need to work with this. Let's move you back a bit. So I'm just going to read something for a second. It's maintained by Lineage. Let's just get it. Even if I don't end up using it, it's going to be useful. I think it's even as a reference. Reflection. And I swear this is just a... Yeah, I forget the... Yeah, there's no packages. I think it's literally just... Let's get a tag instead, right? Yeah. Let's get the most up-to-date stuff. Actually, what Vulkan am I? I think I'm on this version. Give me a second. I gotta make sure I match up my... I don't think it matters too much, but I'm definitely gonna try and match up my my Vulkan version with the reflection. I am on 21. Sorry, 321. Yeah. So 321. Yeah. Okay. So let's grab that. Just so we're working with the same thing. Everything's like chill. Hello, guys. Yeah. Yeah, I'm gonna throw this into my CMake. I think that's the next step. Because we already have the magic number thingy. Assuming that I've typed out the right thing. Let's extract this. So what do we actually need to use here? Let's go back. Now, I swear this is just a header library. Usage. Yeah, okay, so let's throw this into here. Change the language to C. I think it's C. Yeah, okay, so we need the shader modules. All right. Oh, this seems quite nice actually. So you just need the reflect header. Okay. All right. Doesn't seem too bad. You know what I might do? Instead, I've just realized I'm kind of downloading the source code. I should be making this so anyone can use this technically. So let's clone the repository instead. If I clone it, then, you know, I can update it very, very easily. Nope. I do that in a minute. All right, clone. Get this. Okay. Oh, didn't I copy? There we go. All right. Reflect. And then get the tag. Git checkout. Now, isn't it tag slash? No, that's that's not what I wanted. I didn't want a new line. How do you check out tags? How do you check out tags in Git again? I swear it's just Git. Oh, it's checkout. Right, yeah. Right, I'm gonna ignore the AI. I feel like that's wrong. Oh, so it's just checkout tag name. I swear it's just tag slash something, but whatever. That's still got the new line in it, so dump this in here. Copy. All right. Whoops. dr cd sp git checkout. All right, let's just press up. All right. Cool. So we are up to date. Well, we're a little bit behind the most up to date version. Hopefully that doesn't bite us in the butt, but we now at least can add the code that we need. So if I'm not mistaken, yeah, we don't need this. This is the downloads. Let me get to my repository. All right, vendor. So I think we only really care about that. Yeah. Why is it so deep? Interesting. Examples. All right, cool. We got some examples to play with. Okay, this is a much better idea than writing my own parser, then using this. If we've got examples to work with. Okay. Yeah, because we do need to build up our custom struct. It's not exactly the same, but it looks like this is a bit obtuse, admittedly. What is this spitting out? Input variables. Okay, so the spy. Oh, so this is the spiv code. Yeah. So we're just reading binary data here. We need to give it the size, and this is just a local variable. Okay, this is quite straightforward. So we need to make sure it's parsed, I guess. That's what that means. And module variable count. It looks like we do this twice. Is this the same? Yeah, so this is like classic Vulkan where you have the same thing twice. It tells you the variable name. Sorry, how many variables you have. So this tells us the input variables. So all I'm interested in is basically the descriptor set layout for now. But I'll try and parse it anyway. I think we can work backwards once we get the results. Once we get something out of here. Okay. CMake. What do we want to do? We just want to include that header, right? And we need. Yeah, I'll use the examples as well. Let's not be silly here. Let's but first things first. Grab that. And this is going to be used in the graphics, so oh, yeah. We need the SPRV reflection stuff. Oops. No, there we go. All right. Right, so this might be a bit of a exploration sesh. Hopefully everyone's up for that. Considering we're starting something new today. As we are officially done with bindless. Wahey. Okay, so this needs to be included in... Where do I want to include this? The graphics stuff. So that's the void. I don't think I need it there, but I might come back to that. We don't need it in foundation. Where's the... So we definitely need it here. No, we don't. Sorry. What am I trying to do? Oh, void. Oh my goodness. Brain fart. This is the graphics. I forgot I decided not to split up graphics from the main application. Alright, so I will build, sorry, reconfigure even. And hopefully, if I go into, where would I put this? Let's just stick this for now in main, like everything else, the main dumping ground. And throw this here. So includes BRV. What's the acronym? It is. This is just so I don't make sure. This is so I make sure I don't end up not, you know, I spell it wrong and then I'm spending like 20 minutes looking at the CMake code. Right, okay, so cool. We officially have spiv. Cool, cool, cool. Right, okay. That's the magic number. So that's good. All right. What have we got here? Actually, it's probably not a good idea to look at the header right away. If we have examples, let's just see. Oops. Let's actually, what I'm going to do is look at this CMake file and just see if I can actually build a Visual Studio project. So I have something to look at alongside with things. I don't actually know if that's actually a good idea, if that's going to work, if it has everything we need here. Oh, we need the C header. Right, okay, so it looks like it isn't just a header file. Am I tripping? Let's just see. Include. I didn't see any source. In examples. Yeah. All right. Well, let's just run the CMake and see what happens. Yeah, because that'd be really helpful if we could just take these, throw them in, just for future debuggability. Okay, so okay, so they're here. I wonder if I've hang on, 153. All right, yeah, we need to see these examples like proper. All right, clean. See if this builds. So I could not find that. So what are you looking for? Examples. Okay. Which I believe are these. All right, let's do that again. Cool. All right. Examples. Cool, cool, cool. All right, so set a starter project. Okay, so let's just see how this works. Right. Print descriptor sets, print bindings. Okay, cool, cool. Seems pretty good. We don't have that for some reason, but that's fine. Why? Okay, maybe it isn't, but is that the only error? What are we missing? So if I take, where's main? Main descriptor. All right. Okay, so we take the code, which I assume is that. I wonder if this is just the SPRV code, just in bytes. What is this? Imported from. Oh, okay, yeah, that's definitely true. Cool. So that's actually just in binary form. So we create it. We do success. We enumerate descriptor sets, which is what I care about, to be honest. That tells us if it's a success. Then we have this guy, which... Oh, okay, that's really cool. So that has the bindings, that has the binding count. Okay, cool, cool. Because that's all I care about. This is all I want to do, really, right now, at least. And... what else have we got here? Okay, so... Right, I think for now I'll just try and get this far. If I can get that far. So I just need the actual binary data, which I think I still have access to once I compile the shaders. I don't think I actually... I just need to not close the file, I think. It was like, I don't know, at least this far. Like, let's just try and get this far, and we'll see what we can get from there. Okay, so SPRV reflection time. Let's just see where our shaders are. Where did I compile these guys? Okay. So here we have the binaries. This is just a struct with binary data in. That's the actual data. That's the size. Okay. And then we build up the descriptor sets after that. So this is like a good place to put it. Because here is, instead of writing them manually, the idea is that we basically have this struct built up by what we've parsed. If that can work, I'll be very happy. There'll be a couple of things I have to deal with, like the bindless stuff is a bit different, but a bit weird. Anyway, so SPRV reflection. Let's see how far we can get. So obviously this isn't going to work. Okay, I didn't expect the first thing not to work though. Is undefined. Am I being daft by not including? So that's the header, right? Do I need to like define a turn on macro? Like, what is it called? Maybe I should look at the examples again. Oops. Where are they? So here we have common, which I assume is always the same. So SPRV reflect. No, this has a completely different... Ah, right. Okay, I don't include... Okay, I know what to do. Okay, so I need to change my CMake a little bit here. I've included this, thinking this is everything. It's clearly not. So this is still needed, but this is needed in the vendor code. Where it's like exclusive. Foundation, where's external, sorry. External. Why did I... Oh, whatever. I'll put in both. So this needs to go here, and then we just need to include in the vendor code the SPRV H and C. I'm assuming this is exactly the same as the C++ is just a wrapper. Yeah, okay, so it should there's almost no point including that, to be honest. But these are the actual guys that we actually care about, and these need to be in the vendor. So going forward, we have this, and let's duplicate. No, actually, let's not duplicate. Let's take vendor. SPRV reflect. What's the file called? The folder? Yeah, sometimes I'm glad I stream for this reason alone, that someone just in chat gives me the confidence to just just try something. Very much appreciated. Whereas before I'd be like, oh no, I've got to parse it myself first. Right, okay, so that looks like everything will be included. And hopefully we get things that we need in the main. Reload. So this is still, thankfully, a very simple engine. And we need to include not this. Reflect.h. Yes, okay. Nope, we didn't like that. Where is this then? So, if I go to the example, we can see that, no. Get out of this. Go back. Where's main? There we are. Okay, so where does this live? Okay, so this is in SPRV reflect. Oh, right. Okay, that didn't work. That's why. Am I doing this? Am I making a typo? I've got a very bad habit of typing like SPRV reflect, but you know, getting the SPRV wrong. Right, does this work? No. So this would mean that I would wait, I still need to access. Yeah, okay, so I've missed something out in the CMake. Despite, right, let's just compile external. That's the first thing we should check. Okay, so external works. Yes, okay, so that's perfect. And that's fine. Do I need this? I'm going to try and get rid of this, because this would be nice if I could... Oops. This would be nice if I could not use this. Yeah, because that... It just makes things a bit scruffy if I have to have two includes. But we'll see. So I'm gonna build external again without that include. Fingers crossed. It knows what to look for. Yeah, okay, so that's good. That's good news. So now I can use this to... Oops. I can use this instead. Pull this all the way back to here. And then put this in the graphics. And we should be good to go with actually getting things working. Build systems, am I right? Now, to be honest, this isn't that bad. All right. Rebuild. Reload. And now we should be able to go to documents. Yes. Okay. Hopefully the first struct does work. Yes. Okay. So this exists. We have the reflection. And I believe we just need these two here. New binary second rather than first. And size first. Okay, so that's just for the vertex shader. Let's do our pointless, our silly wrapper to make everything cooler. Yeah, I think result might be redefined. So I'm just gonna SPRV, I don't know. Yeah. I don't know. SPIRV, SPIRV results. That's definitely not redefined. So we won't get any redefined behavior, redefined compilation issues. So we have the module which builds up a, what does this build up? Okay, so a bunch of cool stuff. It has the entry point, cool. Which is main, obviously. Okay. Alright, so this builds up all the basic stuff that you could want. Like the language version. Alright, so it actually has a lot of stuff. Is this everything? Anyway, well, let's just run it and see what happens. Okay. So, let's see. Yeah, too few arguments. I should really fix that in a minute. Alright, so what do we have? Do we have success? So this is value of 0. We have 0. So this correctly passed this. Great. Oh, I see. So how do you compile it if you have multiple entry points? So let me see if see if I'm understanding this right. So you have different entry points in one SPRV file. So does that mean you have like vertex shader, fragment shader, compute shader, etc. All in one file, and then you compile that one file into SPRV? Is that right? Or am I misunderstanding? All right. Yeah, pretty much. Okay, so how do you compile that? That's the next question. Because I have like a... I'll show you my CMake. So I have basically this. And it's here, which basically, you know, based on the GLSL's... sorry, let's just see this GLSL variable. Where are we? Okay, so what this does is it gets the GLSL's like dot vert or dot frag or dot whatever. You can have many entry points in one SPRV file. I had no idea. That's interesting. I might try that actually, because as you can see down here, I have like 2 shaders. That might simplify things quite a lot. Ah, right, okay. That makes sense. Interesting. Okay, that might be a shout. I might... Right, before we try that, I think I'm just gonna slowly go through just the vertex shader. If it gets too complicated in the sense that we have to balance like 20 different structs. So yeah, if we have like 20 different structs and we're having to like juggle this and that or whatever, then I might try that where we just like kind of have pairs of shaders together. And we have like, you know, like, let's just say like 6 shaders that all kind of have the same thing in common, that all need the same descriptor set layout. Stick them all in one, then we can do SPRV based on that. Obviously I only have 2 right now, but I'll give that a shout. Yeah, I will. There's a command line to combine SPRV. Interesting. Okay. Right, okay, this is all new territory for me. This is exciting. Right, let's just see what we can get out of the example code, right? So the example code that we were looking at... Yeah, this seems pretty cool that they got example code. Let's just throw this in, right? And... What the heck is going on here? Ah, okay, this is interesting. So this looks like it's showing you how to parse this thing, because that's what I was a bit nervous about. Like, how do I actually get this stuff out? Interesting. Okay, so I'm gonna have to fix this macro, which is completely chill. Set number, descriptor set info, bindings. Okay. Yeah, because effectively I want the same idea, except not quite this. I might end up defaulting to this. I don't know. but I usually use another wrapper on top of this. But I'm kind of like, that was what my old engine did. It did so many layers of abstraction, I kind of got sick of it. So I might actually carry this around if this BRV's reflection is easier. Anyway, let's just see what we can get if we go another layer down. So, all right, result. Oops. Okay, so I'm a bit of a stickler for like using null pointer instead of null. So I assume this gets a count, and then we get. Oh, I see. Okay. Let's use our SPRV link as the tool. Comes with the SDK. Brilliant. Honestly, thank you. That might be what we end up using. Because if we can do that, assuming that it doesn't break the shaders, I might do that tool that links all the SPRVs together to have single entry points, and then ship that over to the users or the gamers or whatever, to then because I'm not doing what I did originally where I compiled the shaders on people's computers. There's a whole, it's like 20 different things I did wrong when it came to dealing with shaders on other people's computers. But yeah, if we can reduce the amount of time that we're having to parse individual files, like reducing disk access, because that's really slow. You know, it's like way slower than going to main memory. That might be a really good idea. But let's yeah. Let's see if we can even get like anything working at the moment. So right. So if I want to use my own array, it needs to be yeah, I have no idea how big this is going to be, so let's call this, yeah, let's just call it sets. There's no reason. Sets, and because it's lovely like C, we don't have to worry about any weird C++ template compatibility thing. Thank goodness. So allocator. So yeah, I'm going to use my main allocator. Initial capacity will be count. So that's the size. Sorry, that's the capacity, that's the size. And data. Right, okay, so get rid of that. And so I don't forget, I'm assuming I can probably throw this away here, something like that. Because we would have built these pipeline creation structs, which then go into the graphics pipeline thingamajig. All right, let's just see how far we get. All right, cool. Still works. How do we do success? Okay, what's the count? 2? It has 2 entry points, right? Oh, it has 2 descriptor sets. Oh, that's exactly right. It's 2 descriptors, sorry. Yeah, no, 2 descriptor sets, because that'll be the 2 uniforms in the vertex shaders. Cool. Okay, so it wrote out capacity of 2. Yeah, we don't really see that well into it. It's not like as convenient, but did we get success? We got a success. Okay, cool. Let's continue onward and start again pulling code from the example. So has header. Let's just see. Is there a way to get this in here, or Vulkan directory found? Oops. Where would that be? Oh, projects. Maybe, yep. Projects. So examples. projects. It's not that difficult to fix. We can just modify this CMake file. Give me a second. This is really loud. Yeah, he's getting blasted off. Okay. Compiler include. So that just needs to be the include directory for our CMake, which we can do. I don't know why it hasn't done what I've decided to do with my CMake. I mean, it's only example code. It's, you know. What have we got? Okay. That's what we want. Yeah, let's just grab this, because that's where our CMake code lives. That's CMake code, our Vulkan code, and then we can just throw this into our target thing. Eventually, I'll take all this out so we can actually update this. I'll probably git stash it once it's done. And we should, yeah, add compiler definition. Right, I have no idea where this is set, so I could delete it. Yeah, I'll delete it, because it's possible this is used in different places and it'll cause all sorts of issues because it's got this and yada yada. Okay, and Vulkan. Right, let's just give this a rebuild. All right. SPRV main descriptor. All right, cool. Yeah, it found it. Ugh, this is. It's like they've never heard of white spaces. What the heck? Okay. Right, I'm gonna have to detangle this a little bit. Just all together. Things are declared. They're set up. All right. Cool. That's a little bit easier to read. So what is this doing? This is getting this struct. We've got a number. This is very close to what we had before. It has bindings and it has... Okay. So sets... isets, number of sets. So it goes through a number of sets. We dereference and we get this guy out. So it's a constant reference. Okay. Set layout. So this is our layout. This would be equivalent to our creation struct that we care about. Maybe a bit of metadata as well. Okay, so we have the binding count. So anytime we see this, we have a right. So that's us pulling out data specifically. Oh yeah, so this is a layout is a non-constant reference which is being written to, which is chill, meaning that everything, this is being updated. Okay. So this builds up the bindings. Okay, so, right. And then this builds up this guy. The binding count, the actual bindings, and the set number. Effectively, that's what we care about. Is there anything else that we care about here? Dot layout. Dot layout is this? So what is dot layout? Give me a second. Peak. That's not what I want to do. So without moving... Oh, it's the create info. Oh, okay, yeah, so create info is actually the thing. Set number is... Okay. I think we're probably... Yeah, I just need to map this effectively one-to-one with my version. Okay. That's what we're going to do. We're going to steal this code, and I think at the very least, once we've got this line and this for loop or whatever, yeah, let's just rob this for a sec. I will put it back, I promise. I'm just gonna borrow it for a minute, guys. Alright, so it has this struct. So we have our struct is called descriptor blah 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 blah. And this has the bindings. That's our binding vector effectively. So we almost have exactly the same thing. We have a couple of extra bits because we do have to say if this is bindless or not right now. What I might end up doing if this gets too complicated in the sense that we can't tell if something's bindless or not, I will literally make two different function calls that handle bindless. One doesn't handle bindless, and we will run with that instead of like a boolean. I mean, this is bad for cache locality anyway, so that might actually be better. But I think this is extremely close to what we already have in the example code, so that's really good. If not, we can modify it. So it builds up a list. Yeah, we can probably build up a list of these, an array, but this time put it on the stack. If we do that, then I don't know why people like using underlines. They look like underscores. Snake case, I think it's called. Like camel case is so much better. Sorry if anyone. Sorry if I'm causing a holy war on the internet, bringing that up again. But I don't know. I just never liked snake case. You just gotta push shift. It's like I'm constantly doing a capsule. I don't know. Anyway, so we're gonna basically replicate. So I was getting a bit distracted there. I can't wait. This could be size T. So yeah, this could be a uint64. Let's just assume this could be absolutely massive. Set index. I'll go with I for now, just because I'm not exactly sure if I want to use set index. Set.size and ++ I, and here we go. We've just got to make our vector, and like I said, I'm going to use the temp allocator, I think I called it, or scratch allocator. I don't think it's that big, that's the thing, so we're going to be accessing it like an array. Oh, is the set layouts already? Oops. No. Why are you complaining? Oh, that's why. It needs a pointer. Right, okay, so we've got that far. Effectively, I want this to work based on I. So we do a dereference. reflect set. I'm probably going to rename it to reflect set. No reason. And then here we have, hang on, it's doing something a bit more advanced actually. It's allocating all the, so it's actually using some C++ stuff I don't think my array has access to, where it allocates basically empty structs for everything. I mean, I could memset, but that's what I want to do. Do I want to memset this data to basically be empty structs? I mean, does it matter if we're going to overwrite everything anyway? I mean, what we could do, because we are going to allocate. I could just access this array and just like clear it. That's the first thing we're going to do, is we're going to clear, just for simplicity, at set I, it's just going to be equal to a blank struct. So that's going to effectively do this. Not all at once, but individually. And then we can... Oh, why do I want to do this? Do I want a non-constant reference? Let's see if I can... I don't know if this is a thing that you can do in C++. In C, set layout plural. And then we take that and go, okay. First thing you need to do, set layout, is initialize everything to 0, because I'm not exactly sure what you are set to. And what I'll do is I'll see how far we get based on that. Do we have something that makes sense? No. There we go. Hey guys, how you doing? Hi Relix. Hi Kalia. Hopefully I'm saying something that sounds like your name. Hope everyone's doing well. Yeah, thanks for joining us. We're doing some I'm starting up doing some SPRV reflection to try and extract the descriptor set layouts in Vulkan from the shaders, rather than having to write the descriptor set layouts ourselves. So, yeah. And I'm just going to make sure that we're not doing anything insane. Ah, yes, thank you. So your bindings, everything's fine. Yep. Bindings is false. Okay. Thanks, Direct Flame, for inspiring me to do just rip the bandage off and rip the plaster off and just get on with it with the reflection stuff. Yeah, Will. Thank you very much. So Relic said, so you write the descriptor set layout specifically to specify the descriptor set in the shader. Yeah, basically we do something like yeah, hang on. We compile the shaders, then we decompile the shaders, and then we pass the decompiled opcode. So for example, this has a this, let's just see, scroll down a bit. So this is like telling us that we have some kind of uniform or some kind of buffer with these data members in. And then down here, this tells us like what it is, right? It tells us that it's a uniform with these variables in, meaning that we can, based on this decompiled shader, we can work out what our descriptor set layout should be. Yeah, so that's our goal. So, oh, my bad. We'll give that a shot. And yeah, we're on a good. So far so good. That's the. I think we're having success so far. So we've currently parsed the results. Now we're just trying to extract it out of the data structure. So your name is it? Do you pronounce the H? I'm pretty dyslexic, so is it Kalya or like Kahalya? Is it? I'm not sure if it's Kahalya or Kalya. Yeah, you have to excuse my terrible spelling and stuff like that. You might even see me type out some gibberish when it comes to writing out some comments. Yeah, I wasn't. I'm not wasn't the best speller in school. I can say that for certain. All right. Oh, and here's the other exciting part about SPLV reflection: that direct flare has mentioned that you can actually combine shaders together. So that might be really cool because I can maybe then send the users a combined shader that doesn't need to be parsed individually, meaning that we touch the disk a lot less, meaning that we get a lot faster when it comes to dealing with files because we're doing it way less. Anyway, so yeah, let's keep digging. Let's keep going. So I'm currently working through the example code because if I can create this descriptor set creation struct exactly the same way as this, then we are like golden. That's exactly what we need to be. But yeah, it's so we need to add the bindings to our creation struct. I think that's the next step. Yes. Okay. So we need to create a struct. Okay. So I'm gonna copy this over. Throw this in here, and then we're basically gonna build this struct, this binding struct. Just called binding. So is it public? Yes. Okay. So let's go back to main. Can I just? Oops. Not that. And this has binding count. I'm gonna rob this. And do this. Cool. This is uint 32. Binding index. It's like I prefer that. All right. Current binding. So initialize that. Not sure. We're not trying to build like a big sorry, it's not like we have a super shader that has everything in and it's just like 1,000 functions that all, and then we have like one entry point, like with one void. The idea is we have according to direct flare we can combine the entry points of the shaders. So we have like, let's say, compute, vertex, mesh shader, whatever, and then all those like void mains and all that kind of stuff. Just kind of like, instead of having it in individual files for the for non-SPLV reflection, this is what I'm imagining. We then parse that one big file. We reduce the amount of parsing we have to do because we're not picking up little files. We're picking up one big file. I don't know. This is all kind of new. So yeah. Oh, I need to change that count. Ugh, it's gross. So that's I don't really know that much yet. Transpiling. Yeah, probably. Yeah, you probably know more about this than I do. So this is our set layout. Right, so we want to build this guy up with our data. So what are we able to do here? Yes. descriptor count. Okay, this is quite straightforward. So in our binding structure, we have rebuild riff binding. What's that? Oh, right. So this is actually where the bindings live. Okay, let's pull this out. I think I jumped ahead a bit here. So reflection binding. Yeah, so people who are watching who are like, what the heck does any of this mean? Or what was the result of this, I should say. The result of this is we can combine different graphics. We can combine shaders together with our we can more easily write Vulkan graphics pipelines because the shader is dictating what the graphics pipeline is rather than the other way around. Meaning that we don't have to write tons and tons of code. We can just kind of automate it based on, based on this like this SPLV reflection. It's a bit of a. I think I've tried to explain this before to other game developers who aren't Vulkan programmers, and they never really got it. Just because they don't know anything about Vulkan, not because I'm super smart or anything. Or I'm probably just terrible at explaining. That's more accurate. So if it's a bit like what does that even mean though? I've never been able to talk. I've never been able to successfully, someone who doesn't know anything about anything. I've never been actually successfully been able to create, make it make sense basically. Anyway. Yeah, I should just concentrate on this, I think. Okay. So this didn't work. We want to... Yeah, we're not building this up yet. We actually do this later. Interestingly, though, this seems like a so much simpler way than I'm doing it. But I think if I try to like do too much too early, so effectively I just want to fill these up. Okay, so we need the type. What's this then? SPLV thingy. Yeah, okay, so that's the first thing we care about. Reflection binding. Current binding. And this is descriptor type. What's this? Descriptor type. Yeah. Doesn't this map exactly? Oh, this is SPLV reflect version. It looks like we can cast this to our type though without any issue. Oh yeah, it's kind of already doing that here. I'll assume they're one-to-one and not worry about it. Okay, so the next thing is sorry. The next thing is okay, so this is actually the binding count. That's actually what the number is. How does that figured out? Cool. All right, we'll grab that. That's like really easy to do. I'll do that next. So we do this. I think it's just stage And I'll do a C cast. No reason. Okay, so hopefully that gives us the shader stage and the shader type. Double streaming, hey. And it is quite motivating when you have someone in the background. I was doing that yesterday. It's quite motivating. Like, I was coding with them, and yeah, it was kind of fun. So I totally get it. So the count is pretty straightforward. I think this is always 1. Then the start is, again, this is start, admittedly is a terrible name. This should be called index. Start needs to be, how do I get that out? I'll get rid of this for a minute. Okay, so that's the only thing we're missing in this example code. Binding, I think that's it. Yeah, I shouldn't rename that to binding. That's such a better name. I might do that actually after this. So this is just start. I don't know why I copied and pasted this here, but here we are. And reflection binding. Okay. So in theory, we now have a way to add that binding to the current descriptor set layout. Creation struct, which is this guy. So set layout, add binding, current binding. Let's just make sure this works. I don't want to have like some stack corruption. Okay, yeah, so that is doing a copy. We don't want to have a stack corruption. The weird part is this, the descriptor set count. This is probably like way more correct than what I did. So yeah, we're gonna throw this in as well. Oh, this is for dynamic. Ah, that's what that means, dynamic. Got you. Totally, yeah. I mean, I was feeling not motivated at all yesterday, and then as soon as I like popped on someone else on the stream, who was also coding, I was like, yes, perfect. I was doing so well. All right, so it is nice. Dim. I swear this means dynamic, right? Dim count. Dims. What's a dim? That's a good question. I'll just call it dim index. I'm not actually sure. It could be. Okay, I'm a bit foggy on that one. There we go. All right. So now we have bindings. Next we need to the binding count and the yes. Okay, so we need extra bits of data. We need the set index. I'm assuming that's what this is. I really hope it is, because that would be super cool, because we're basically done. Set index. We've got to set index, which apparently is reflection set. Reflection set. All right. Now, as far as I can tell, for the vertex shader that we've passed, that will be the descriptor set for that. The only problem is that's just for the vertex shader, and yes, we can combine them together apparently, but let's think. Is there a simple way to do this without doing that? Actually, before we do that, let's verify this even works. Because it could just crash. It could just go bleh. What are you trying to do, dude? This is terrible. What was this for? Oh, right, yeah, that's we do this later on. Yeah, so let's see. Yeah, because we have so like, how would we know that this is both? Okay, we have something to compare against, I guess. Why did I say it was false? This should be true. Whatever. Alright, so right, well, actually, leave that there. Leave that alone. We need to be coming out the code that doesn't work. I just want to see what we end up with once we've done this. Let's just go. Woo! Is that Morpheus? Morphus? Yeah, thanks for turning up for the stream. Hopefully you're having a good day. We are in the midst of writing some SPRV reflections. So capacity 4, size 2. Do we have anything in it? Does this have anything in it? Binding count 3, set 0. Binding count 3. So that means we will go through 0, 1, 2 in the vertex. I need to have the vertex shader up to absolutely confirm this is fine. Let's get the shader up. The vertex shader, where are you at? Foundation, vertex shader. Why am I going not in the shader file? Okay. So, yeah, we have 2 structs. 1, 2. Okay, yeah, that makes sense. So it's picked up these 3. I forgot I had 3. Okay, I was a bit nervous then. I forgot I have an SSBO. And then for set 2, we have model position, which... What does this even have in here? Oh, I'm at 4. Okay, so... And we have a push constants. I wonder if we can get the push constants out, because that'd be really nice. Currently, I'm just kind of setting this automatically. Sorry, manually setting this automatically. I'm doing the opposite. Alright. Let's go. Right. F10. Right, so we should have like... Yeah, we have error data. It doesn't make any sense, but then when we do this, now we have normal data. That isn't going to barf. Cool. Yep. So this has a count of 1. We have dim arrays. What's this currently? Good. Wonder what this refers to. Image. All right. Yeah. Let's just see these values. So this current binding has start 1, which should be binding, count 1, vertex shader, and if I go in here, we have. So it has picked up that this is in the vertex shader, but it's like, I think it's going to call everything a vertex shader. So, I think I might need to combine these shaders already. Because the problem is, yeah, this is all stages because it's going to be used everywhere. But this is also using the fragment shader. Anyway. But for the most part, this seems correct. Outside of that. So, yep. Let's see. Start. What? Yeah, I'm going to change that to binding right now. Name. Yeah, I don't think there's a name here that would be good for debugging. Source file. No. Entry point name. How hard is Vulkan? Oh, I didn't answer someone else in the chat who said that earlier. My bad. Thanks for asking that again. How hard is Vulkan? It depends on what you're trying to do with Vulkan. I think I've been learning this for like years now. I think Vulkan gets a bad reputation because it's like, I would say when it comes to Vulkan, you've got to study Vulkan or like learn Vulkan like you would be learning a new language. And that's not what people want when it comes to libraries and like how to do graphics or whatever. Because even with OpenGL, like a basic OpenGL application, can be made relatively simple in comparison to Vulkan. And I think that's why it's considered hard, is because it requires a lot more. It requires more effort to get started. With Vulkan, the learning curve is definitely steeper. But if you have that in mind, like the learning curve initially it's going to take you longer to be able to achieve similar results with like OpenGL or whatever, then I think you're going to be okay with the difficulty. It's not like super difficult that like no one can understand it and it's impossible to learn or anything like that. I think people can end up being put off by the fact that it has a steep learning curve. But I think, honestly, if I can do it, anyone can do it. Hopefully that answers the question. How hard is Vulkan? But like I said, it depends on what you're doing with it. Like, you could just be doing compute. And if you, like, let's just say you know how to do compute matrices or whatever. I don't know, let's just say you're trying to find eigenvalues and eigenvectors in a massive matrix or whatever, you know, to find the basis. And you're just setting up the compute. And instead of using CUDA, you're using the Vulkan compute shaders. Like, the amount of work that you have to do to just do a compute shader is like way less than it is for graphics. Graphics it requires more setup, because you have to, you know, talk to the monitor as well as the graphics card. So, you know, like I said, it depends. But for graphics, I think it's I've gotten used to it, and I don't think it's as difficult as like as the learning curve would make it out to be when you're starting off. But that being said, I'm definitely nowhere near like a master or, you know, someone who can definitely be like, oh, I know everything about this. Let's go up. What was this value? 0. Cool. That's great. Oh, don't get me started with mesh shaders. Yes, I did make a video about that where the last video I made 1,200 hours of programming, like a third into the video, and like for the majority of the rest of the video, it's literally just me talking about mesh shaders. So I would have to agree with you that mesh shading is definitely more difficult than you know, just doing vertex shaders and fragment shaders. What do you suggest for a beginner game engine? It depends on. So yeah, there's so many different starting points. Like, it depends on what type of game engine you want to make. I would ask you that, like, what type of game do you want to make? I think that's going to dictate the direction that you want to go in. So if you have an idea of what game, I could probably give you a better answer than just, you know, giving you a bunch of list of resources. Right, so we know that these are all... So it picked up all this. This is perfect. I'm super happy with that. My concern is it kind of just finished. Like, it didn't seem to want to continue beyond that. It only did, like, one... Like, it didn't build a second descriptor set layout. I'm not exactly sure what is required to do that. A 3D, you have a game idea. A person explores a dungeon. Okay. That's better. Okay, so you want to stick to 3D. Do you want to learn about voxel games, like a Minecraft game? Because that... or is it just going to be like a regular non-voxel game? That's not Minecraft-like. Because that again will change. Do you want? Because if you want to make a Minecraft-like game, then the things that you're going to learn, that you should, air quotes, should learn, are going to be different. Again, you want to learn like voxel stuff. No Minecraft. Okay, so yeah, the first thing you should recognize is that graphics, something I think people overlook. The most expensive thing for the computer to do is graphics. The second most expensive thing for the computer to do when it comes to games, anyway, is physics and updating the world. And the third most expensive thing is, user input. And you typically do things in that reverse order. So you do handle input, update world, and render. So unfortunately, when it comes to making a game engine and doing like a beginner game project that isn't like voxels, that isn't 2D, you're going to have to spend more time than you probably would like getting the graphics to be faster you're going to be dealing with all the, no matter what API you use, you're going to have to be dealing with like weird GPU stuff like we're doing right now with Vulkan. So the first thing I would do because of that is definitely learn how to render a complex scene. And if you can do that, then adding the physics with a library even is going to be much easier. You can use intermediate frameworks like Raylib, which give you a lot of like foundational stuff for free, and SFLM as well. I'm not personally using those, but that might be a smart choice if you want to do it yourself. So yeah, it's because of how expensive graphics is. I would definitely start with learning how to do graphics. It's not always, because I actually wanted to learn how to do physics until I learned about how complicated until I learned that graphics are the most expensive thing for the computer to do. Because I thought, well, I want to play a game. I don't want to just like look at a thing. I don't care how bad the graphics are. I want to play it. So I need physics, right? And that there is some logic to that. So if you've never touched Vulkan, like the tutorials are good, but I would definitely focus on spending like a year just like, can you render like a cave with some lights in and I don't know, like an animated player? That's like quite difficult to do because you've got to do quite a lot. Like if maybe literally just spend a year trying to get animation working if you've never done this before. So that would be like learning how to load a model, learning how all the shaders work and stuff like that, and then progressing to animation. If you plan to have lots of animation, that might be useful. Like it depends on the direction. Like again, like is there going to be no player characters with no animation? That might be a bad idea. It all depends. Like your game should dictate what you should learn. Like that's how I would do it. It's like if there's going to be like 3 lights in the game, like super simple, then do you really need to learn really complicated lighting, like ray tracing, for example? Probably not. It's not worth it, right? If you're going to have like tons and tons of animation, then it's probably worth spending a load of time on animation, right? And knowing, like I said before, where like the graphics is the most expensive thing, I would spend as much time as you can learning the graphical techniques that are necessary for your game specifically. And if you've never done Vulkan before, I would start with, assuming that you want to use Vulkan, by the way, you don't actually have to use Vulkan. You can use OpenGL completely fine. You could use all sorts of different tools. But again, if you want to use Vulkan, there's that how-to Vulkan I think I've mentioned multiple times on the stream. How-to Vulkan, which is a good like beginner resource. Another good resource I think is this guy. What I would do honestly if you're starting out is like replicate his engine. Go through all these Vulkan for beginners tutorials. It's not going to give you literally everything, but if you can replicate his engine 1-to-1, you'll be in a much better place to be able to know what to do with it. With your game. So yes, that's a really good point. Yeah, Vulkan isn't really a graphics API, as Relics has said. It's a GPU API. That's 100% accurate. That's why it's so like awkward to work with. Yeah. Relics can vouch for this guy. So yeah, highly recommend this if you want to learn Vulkan. He has been releasing more videos recently. On Vulkan. So if you do want to use Vulkan, I do recommend going through this, trying to replicate his engine. Yeah. Hopefully that's good. Both resources. Cool. Cool. All right, let's get back to it. I also need to read some of his videos. So, right, we're going to change this to binding now because this is doing my heading. Calling this count. Yes, we're gonna break a lot of things doing this. No, yeah, that's true. He's further ahead on yeah, I want to get rid of this finally. With OpenGL, that guy. But that's the other thing I want to do. If I'm going to use this thing, I'm going to have this again, which I don't like, but whatever. But consider it as like a learning time, like a study time to learn that. I would also recommend taking notes. Just do like general good study habits when it comes to binding, sorry. When it comes to learning Vulkan, if you want to use Vulkan, by the way, you don't have to. A lot of the struggles I end up having in 2025 were honestly because I just rushed a little too much. I didn't take my time. I didn't write like all these obsidian notes back in. Get this up. For example, this basically all Vulkan. This big blob here is Vulkan. This is operating system stuff, and this is like performance stuff. But like if you're making like good notes and being able to so you can refer back to, based on what you've like seen. No, that's wrong. Then you'll be better off in the future. There we go. Yeah, just be careful with AI. A lot of programmers end up not getting very good because they end up getting what is it? They use it as a crutch. I'm not going to say stop using AI because that's your business, but I personally don't use it. But that's up to you. It's just I've seen like Wait, this should be not count. Oh, I've changed the wrong thing. I was talking too much. Sorry. Count was perfectly fine. This should be binding. It's just, yeah, just the only thing is the start binding. It just can, you know, I've talked to some programmers who regretted using AI. That's all, because they didn't actually improve. That's cool. So Catlin 142. Oh, cool. That's good that you're double checking at least. It's just you want to be in the position that you can, the internet can go down and you don't have access to the AIs, and you can still do your work. If you can't do your work without the AI, then you're relying on it too much. That would be the metric I use. If you can't code without it, you've gone too far, in my opinion. Because you want all the knowledge in your head eventually. Not in the AI's head. Right, yeah, don't need this anymore. Local variables not referenced. Yeah, sure. Scene count local variable not referenced. Right, error. Right, so this needs to be count. And start needs to be binding. Yeah. I think AI, yeah. AI can be... I use it as a search engine sometimes. Because sometimes Google is absolutely terrible at giving me the resource search results. But I try to step up. I try not to use it for my code at all, if I can help it. But again, this is more like opinion based stuff, and I don't think I don't need to be. I mean, a brilliant coder I know is he's using it for his like an emulator. He's building like an old ARM emulator. But I don't know, if you have all the time to learn this stuff, I don't think, you know, you make basically just be aware you're making a trade-off when you're using AI. The struggle does get you better. Anyway, I don't want to ramble about this for too long. Right, okay, so the problem is we only have one descriptor. How do I get the other sets out? That's the next question. We have sets. Did I do this wrong? Set size. Okay, yeah, sounds good. Yeah. I mean, yeah, just be aware that you're trying not to be... Like I said, I would use that as a metric. Can you code the things, the projects that you're using? You know, maybe you're not as efficient, but if you can't code without the AIs, then you're in trouble. Oh, cool, yeah. Thanks, Relics, for giving us so many resources. I don't know about these either. I'll be definitely checking them out. But anyway, let's... I feel like I've strayed into AI. AI talk. So, for some reason, we are not getting as many descriptor sets as I thought I would be getting out of the vertex shade. Am I getting the right code? Because I have 2 descriptor sets, not 1. Yeah, let's just see. Descriptor set size. Excuse me. Fragment shader runtime descriptor array. But we shouldn't be hit. What? Why is that erroring out? I have a breakpoint. I don't want to go that far. Create pipeline. I am GUI. Oh, I probably messed this up, didn't I? Yep. What was this originally? Start. Count 1. Yeah, that's fine. What is it saying? The fragment shader. Oh. Yeah, it looks like, yeah, global textures, binding count is 0. Why is that 0? Did I mess that up? Give me a second. Binding. Yeah, I might have created a mistake here. Basically, there's no bindless descriptor set being bound to the thingy. To the debug GUI stuff. Okay, I think we're a bit too high up. Yes. F5. Yeah, so we have these guys. Yep. Okay. Okay, so this is us building up the bindings. Blah, allocation stuff. Will do. Thanks for the recommendation there. False. Final is true. Sounds good. Input binding. Start. Wait, what? Oh, this needs to be true. So this is false. False, true, and that's false. The set index is 1. This is false. These all have to be true. What? Give me a minute. We're just going to control Z. Give me a minute. Alright. Why were you complaining? Yeah, let me I'm gonna have to go back to count for a minute because I don't know why that's broken. I know it's not ideal, but start, sorry. It's because it seems kind of stupid why that broke. It's probably because I've overwritten a variable that shouldn't have been overwritten or something. Okay. There was something I wanted to keep there. That. Oh, hang on. Maybe that was it. No, I make them all. I don't think. No, I think that matters. All right. We'll go from here. That's kind of annoying. Local variable not used. Yes, that's by design at the moment. So start. That's likely the only issue. So this is not bindless because this is not a bindless thing. Let's throw this in. Bindless equals false. Okay, so with our stuff that we did in main, is this going to touch anything? I don't think it is. We just have an array that we don't clean up after, which I guess I could just throw this in here just to shut it down. I mean, we could use an index or something. Hello, Ratchet. How you doing? Hope you're having a good day so far. We are doing some SPRB reflection stuff, and I currently broke my graphics pipeline layout for my IMGUI stuff. So I'm trying to figure out why that went wrong. Okay. So that's fine. Right. So now I'm going to do what I wanted to do, which is change something. All I did is change the name to binding instead. And that kind of broke everything once I fixed all the compilation errors. You were reading the DLS programming guide. Ah, okay, yeah. Any new insights in using DLS? Gonna be generating the frames on the fly. I mean, it does sound pretty cool, to be honest. There is a part of me with DLS thinking I'm too macho for that. I need to be 60 FPS with my own frames or bust, because I'm super cool like that. Nice. So you're mainly checking if you had all the requirement inputs already. Nice. Brilliant. Okay, I don't know why I was complaining before, why we suddenly had a broken thingamajig. Alright. Alright, now we can go back to investigating what we cared about. So, we have our parse BRV. We have one descriptor set. One descriptor set layout for some reason instead of two. Color buffer, depth, motion vectors, and exposure. Sounds cool. 2. So it does have 2. Interesting. Wait, am I tripping? Alright, so before I... let's just make a variable. No, you know what I'm going to do actually is not do that. I'm going to extract out my set layouts and just see what's in them. See if our creation struct makes sense. Set 1. Alright, so we should, that should be correct. We should have 2 creation structs with 2 different things in. Ah, fair enough. No, I was only joking really with the frame gen stuff. Alright, let's see. Number of bindings 3. Set index, that seems to be good. What about 2? You should have set index, yes. Yes. Very nice, very nice. We have a storage buffer, very good. It's in the vertex shader, very nice. The problem is it doesn't quite know why. Okay. So I have 2 files, and I want to parse both of them at the same time. Can I do that? DLAA. Nice, okay. New tech. Yeah. Well, good luck with the upscaling. Out of curiosity, what are you planning on like running on like really huge monitors, or is it just something that's just going to help you out with because of the ray tracing when you're upscaling? Just curious why you want to upscale. If you just want to do it for fun, I don't know. It'd be interesting to still know. Okay, so this is the shader code. Right, I'm going to scroll up because someone was talking about a... what is it called? SBR link. Let's have a look at this link thing. I can't... Oh, hang on. I need to go in live chat, don't I? There we go. I don't know why YouTube has 2 different chats in the chat box. Live chat and the other chat. Okay. Right, so we have a... What's this called? SPVR link. Right, there it is. And lint. I don't need a linter. Alright, let's look at the GitHub project. Oops. Let's just speed off tools. Validator, optimizer. Not too interested at the moment. Diff. What I want to do is squish the binaries together. Alright, I could probably just search this guy. Yep. I think it combines BLV binary modules together, resulting in a single binary module as output. This is a work in progress. The linker does not support OpenCL programs. Okay. A standalone linker. All right, let's investigate. Let's see what this does. All right, I'm probably just gonna play around with it here, just to see. I just want to see the help page of this. Elk. Is it .h? Let's say -h. Sure. How do I input and output files? Ah, okay, so yeah, I'm kind of curious, like, if you just have one. No, I think it makes sense to combine SPRV files that share a descriptor set layout for this reflection thing. I wonder if I'm going to try and combine my files together and just see if I can create shader modules with them. Let me just scroll down. Because if I can create shader modules with these combined shader files, that might be a better way of doing this, so I can access the disk less anyway. Especially if they share, like I said, descriptor set layouts for reflection. Okay, right, yeah, we're going to be writing stuff in Notepad. Very cool. So this is my no. No, I don't want either of these actually. Don't save. What we want to do is go into my Git and the actual shaders. Yeah, so for now, we're going to go into the build directory and do this. So the experiment is, can I combine these together, create shader modules, and then do spiv reflection? The problem is the stage might be a shader of all graphics or something for every single thing, but that might be relevant. I don't know. All right, let's command line. I don't know. For now, I'm just gonna kind of explore. So, SPVR. Ugh. I always forget the names of things. Let's see. Shader. Vulkan, where are you? So the combiner is called. I just want to absolutely get this right because it's really annoying when you don't. Okay, so it looks like binaries are read in as inputs. And the output is... Oh. Okay. Do we need to... Sure. I'm going to do the output as... Yeah, I'll do the same thing. Spiv. Output. I don't know. Quite lazy right now. SPIOV. And the inputs are the shaders. Let's go to the shaders. And see if I can combine them. That's not the shaders. Because this might be an extra bit of CMake magic that I might have to work with. Or not, I don't know, because it's kind of like some shaders I want to combine, some shaders I don't want to combine. I don't know. It might be better to write the shaders in one. I don't know. I don't know. One thing at a time. Let's see if we can combine them first. And just see what it spits out. And one, can I create and can I create shader modules with this? So let's see. Is that how it works? Right, okay, cool. Now question. Shader modules, do you work with this? Okay, so I just need one. And then I can go like this. And the only thing that's differentiating them is that. Second question is when I'm doing spiv reflection for descriptor sets are shared among shaders, is this what we care about? Let's see. Okay. Oh, sorry, I missed some. I missed some chats. I was scrolled up. Performance mostly, but DLLA looks so much smoother. Okay, nice, cool. Oh, I won't actually know if that worked. Why are you trying to combine shader files? Access the... Yeah, I'm trying to access the disk less. That's always a positive. The second thing is when I'm doing SPRV reflection, it can't see into the fact that I have descriptor sets across two different shaders. So I'm just kind of curious if it can... If the output of this can figure out that I've got two descriptor sets that are used in two different places. So yeah, I'm kind of curious about that in particular. So yeah. So there's a fragment shader one. There's a fragment shader. Uniform buffer. Uniform buffer. Thanks for joining us, by the way, Carmen. Sinful Bobcat. Nice to see you again. Hopefully having a good day. I'm trying to make a game engine, my first in Java, using OpenGL and a lightweight Java game engine game library. Since you seem to be experienced in game engine dev, any advice? Any advice on that with Java? What would I say? I think if you're making your own game engine, just try to keep it fun and try to keep it simple for now. If you're brand new. Try to try to do what try to keep it simple. Like, I think starting out with an idea like you're gonna like recreate Unity or Unreal or something like that. Obviously, I don't think anyone's thinking that, but watch your constraints, watch your watch your requirements. For example, people are criticizing me, maybe rightfully so, that my constraint here in this example that I'm worrying about disk access might not be an issue, and I'm increasing the complexity of this BLV reflection, right? So this is something that I also need to be aware of. And if you're working with your own game engine, it's that you also need to be aware of. Your constraints can make problems that end up making things take forever and are really difficult. Think about your requirements. Like, constraints and requirements are slightly different, but they're the same thing. You can end up requiring that you need to do this and that and have threading for your engine, etc., and all that kind of thing, and you don't really need threading. Maybe you just need to make a fun game that you're going to play with your friends, and they have a beast of a computer anyway, so who cares? You know, that's like a thing that you need to think about when you're coming into contact with games and stuff like that. The only reason I'm thinking of disk access is because it's just a nice thing to have if you can get rid of disk access. So yeah, think about your constraints, think about your requirements, and try and keep your scope as small as you can. Like I said before, just keep things as simple. And yeah, you should have hopefully a nice little game with your game engine, Simple Bobcat. So hopefully that's useful. Yeah, so what I'm trying to do here with this combining of the shaders, I just don't know how to read two different shaders in, that's all, into this reflection thing, and it pick up like this, for example, this shader stage, or because I use this across two different shaders, so vertex and fragment shader. I don't know how to be like, guys, we're using vertex and fragment. Yeah. Yeah, good luck with things, Simple. Yeah, this is the thing. I wanted to automate graphics pipeline creation. It's just really nice if you can get it working. So I can have like multiple combinations of things. But I think I might go back and just figure out how to do this regular. Because if I can just get this working, this would be super nice. Because I'm pretty close. So, let me just restore this so I don't break everything. Fragment. Okay, so we have fragment. Maybe I just need to make like two different modules or something. Let's see. Right. Yeah, because I haven't even explored how to do this without vert and frag. All right. So this was the thing. I will do fragment below this. Frag and frag and frag. So we should have two different modules now. Just seemed a bit scruffy, but I'm not worried about it now. Use shader code between shaders and C++. Shared shader code. Like I'm doing with So here's what I'm trying to do. I'm trying to attack this. So the module here. I wonder if I can simply just combine these two. Have a look at that in a minute. Let's go back. Yeah, because I think this is literally as complicated as it gets. If I could just loop through this, because I already have the sets. Maybe I'd... give me a second. How do I... I think I've just got to... Yeah, then I've got to append things on that haven't been added, which is fine. Ugh. Stop pausing. Oh, by the way, definitely recommend checking out this random song that I found ages ago. It's so good. You know what? Screw it. I'm going to play it. I don't get any money from YouTube anyway, so you're going to listen to some music briefly. This is just so good. I hope it's not too loud. This is just for the tutorial. I've never even played this game before. Here's right, my stream immediately gets crashed or something because YouTube. Right, I'm gonna... what I'm gonna do is investigate what these values are and see if I can all them together or something. So this will be the vertex one. Stage. Duplicate that. Fragment. Okie dokie. So let's just see what these are then. I think I'm doing everything right here. No, I'm not. These have been I've got to make these different as well. Otherwise, I'll just be redefinition issue. And I want this to be frag for a minute. Okay. And shut down. Duplicate that. Frag. Okay, so. Yeah, that's true. I could just make one descriptor set. 1 giga descriptor. Just update that. But there is the only reason I don't do that is because updating them, I can separate out the ones I'm updating all the time with the ones I'm updating like very infrequently. That's the only reason I separate them out, which I've heard is good practice. Let's just see what these guys come out to be. Oh, I'm doing a different module from a different descriptor set thing. I don't think that makes sense. How do I know which ones I've got in a different shader? That's the next question. Why is this song so good for a tutorial? I'm gonna just have to look through each shading module. I don't know how to figure out which ones have been added, which ones haven't been added. Because let's just say I have 1 in the vertex shader and 7 in the fragment shader. How do I then go, which one is the duplicate out of the 2? I think I might need to investigate these structs a bit more. You can update different sets with different... Oh, I see. Yeah. You can probably do that, actually, now I think about it, with descriptor heaps, right? You can probably allocate... You can index into a buffer. Not that. Excuse me. Turn that up. Sorry, music's gone for now. Cool song though. Oh, just regular descriptor sets? Yeah, but doesn't that defeat the point? If you update a descriptor set, every draw call, every model instance, and every frame, isn't that just updating it every draw call? Anyway? Ah. Yes. Carmine, that's exactly what I need to do. I need to check through the stuff that's already been allocated. Check if the set index is the same. And then we can figure out if we have a duplicate. Very, very good. Let's just do that. Oh, it's not the same? The thing, what I was thinking of is module shader, descriptor binding. So I need to be skipping stuff on the second for loop. No, that's not right. I think you can have control over when you update the descriptor set, but if I have like a big descriptor set and I'm updating it every draw call, but only half of it, and then I update another half I don't know, every frame on it, I'm still updating that descriptor set, even if it's just half of it, every single frame. Every single draw call, no matter what I'm doing every single frame. So I'm grouping all my resources together when they're going to be updated. Like these are going to be updated every frame. These are going to be updated every draw call. That's the reason I have different uniform buffers and stuff like that. Right. Okay. So if right, let's think. If we have a set layout, no, we don't want to be doing this now. I'll just be wiping out all our progress. So our set layout, if, no wait, okay. When No. This is correct. Set layout. So we set this here. Yeah, that's what I want. If set index is equal to this, we have a duplicate, meaning that we need to update it, not erase it. This, else. This is what I've learned in the past, basically. You want to group resources that you're updating in your shader into groups based on how often you're updating them. Apparently that's optimal. Apparently that's what I learned from an old YouTube tutorial. I can link it. I'll link it in the Discord while I'm online. Brandon Lia. You might have. I mean, this was like. Is that right? No. What was this guy called? I talked about him all the time when I was making my early videos. My horrendous early videos. Your videos. I think I credited him. That's it. That's the guy. Let me just get this up. This guy, and it was the descriptor set video. I really like these tutorials. These were really useful when I was learning. This one. All right. So I'll just throw that in resources. Joop. And you can watch that at your own discretion. If at all, you don't have to watch it, obviously. So yeah, anyone who's watching, this is my Discord server. The links are in the description if you want to join. That's a good point. I've never thought about that. Yeah, bindless. That makes a big difference. Are you doing bindless, by the way, Ratchet? Because if you're not doing bindless, if you are doing bindless for every type of uniform, then that makes a big difference. Because then you just bind them all at the beginning of the frame anyway. Who cares when you bind it? Yeah, Carmine's completely right with that. Right. Anyway. Yeah, because bindless is better. You'd want to use bindless. I haven't yet moved everything to bindless, just textures for now. Right, what am I doing? Okay, so let's just check this works. And we do have like I've been a bit distracted this stream, admittedly. So this is weird. Well, not really. Let's just see what ends up turning up. So we end up doing exactly the same stuff. Okay. Completely changes the subject then, yeah. I think we were talking across each other because I was talking about non-bindless, you were talking about bindless. I'm sure that is very efficient then. What do I have? Multiple redefinitions. Yep. Count is used twice. Set flags, is that used more than once? Oh, set frag. Set vert. count. Yeah, okay. That's the only issue. Oh, no, I'm sorry as well. I need to be thinking more in bind lists anyway. Yeah, okay, this is great. And this is the fragment stuff. So we have binding count 3. And if I look at my fragment shader, do I have this? No, it's the vertex shader. Vertex shader. Ah, okay. Looks like it's time for me to head off. Hopefully everyone's had a good stream. I've enjoyed myself. I've been very much informed by everyone. Thank you for joining me. I will keep working on this probably outside of the stream. But yeah, it's I can't stream all day, unfortunately. Yes, join the dark side, my friend. I will go. I will go bindless eventually, 100%. Anyway, thanks for joining my stream, guys, and I'll see you